in this proof, we have to prove that line segment HA right here is congruent to line segment DE. To do that, we have to prove that these two are congruent so that we have enough information for these, and so on. So the first statement is angle HCD is congruent to angle HGD, and we know this because it was given information. Also, we know that line segment HD is congruent to itself because the reflexive property congruent says that it has to be congruent to itself. And next we have line segment HE, right here, is parallel to line segment DA because it was given information. Then we have angle GHD, so GHD, this little angle right here, is congruent to angle CDH right here, because since we know that DA is parallel to EH, and this line is a transversal that cuts through both of them, we have to say that these opposite angles are congruent, and we know this because of alternating interior angles. Therefore, we have enough information to say that triangle HCD is congruent to triangle HGD because of angle-angle side congruency. Now we have enough information to prove that these two triangles are congruent. So angle HCD, this one, is congruent to HGD because it was given information. Then we know that angle HCB right here, plus HCD right here together, they make 180 degrees because of the definition of supplementary angles, and we can also say the same for these two angles. Now, because of algebra, we can say that if I subtracted the value of HCB from 180, the outcome would be HCD, and the same for these two angles. Also, since this angle is congruent to this angle, and this is congruent to this, we can substitute them within the equation. And because the transitive property of congruence says that if A is equal to C, and the value of B is equal to C, since they're both equal to C, A and B have to be equal to themselves. So we know that angle HCB is congruent to DGF. So now we can say that line segment HC right here, is congruent to line segment DG because of CPCTC. CPCTC just means corresponding parts of congruent triangles are congruent. And that means, since we know that these two triangles are congruent, automatically every part of these triangles must be congruent. So now, angle HBC and angle DFG right here, those are both equal to 90 degrees because we know that these two line segments are perpendicular, and perpendicular lines create 90-degree angles. Now we have enough information to say that triangle HBC is congruent to triangle DFG because of angle-angle side congruency. Now we can move on to proving that these two triangles are congruent. So line segment HB, this line right here, is congruent to line segment DF because of CPCTC, which means corresponding parts of congruent triangles are congruent. So since these two triangles are congruent, these lines have to be congruent to each other. So now angle HBA and DFE are equal to 90 degrees because we know that these lines are perpendicular, and perpendicular lines create 90-degree angles. And we also can state that line segment AB right here is congruent to EF because it was given information in the beginning. Therefore, we can say that triangle HBA is congruent to DFE because of side angle side congruency. Now that we know that these two triangles are congruent, we can now say that line segment HA is congruent to line segment DE because of corresponding parts of congruent triangles are congruent.